we have this question. If s plus 1 over s is equal to 3, find s raised to power 3 plus 1 over s raised to power 3. Let's solve it. We have s plus 1 over x equal to 3. Now, we want to recall something. Recall. If we expand this using Pascal Triangle, we will note that we are going to be having some coefficients which you can get by Pascal Triangle, which is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Now, whenever we have the power of 3, this will be the coefficient of it when we are expanding, because when we have something of this nature, we want to expand. If, for example, if you have, let's say you have a plus b squared. If you expand it, you are going to be having a squared plus 2ab plus b squared. How do we get this thing? These are coefficients. Coefficient a is 1, coefficient a is 2, coefficient a is 1. How do we get it? We get it using Pascal Triangle. When we have the power to be 2, the coefficient is 1, 2, 1. This is 1, 2, 1. So if we have the power of 3, the coefficient will be 1, 3, 3, 1. So how are we going to get that? We can get that. Let's just expand this thing using Pascal Triangle as coefficient. We have s plus 1 over s raised to power 3. If we expand this thing using this as our coefficients, we are going to be having 1 s raised to power 3. This one will be raised to power 0 plus, we are going to have 3 s raised to power 2. This one will be raised to power 1 plus 3. That's the coefficient. S raised to power 1. This one raised to power 2. Then plus the last one, which is 1. S raised to power 0. This raised to power 1. Raised to power 3. Now, what do you notice there? We notice that as this one is decreasing, this one is increasing. When we have 2, we have 3, we have 2, and 0 turns to 1. That's one. This one is decreasing, and this one is increasing. When this one is 2, this one turns to 1, and this one is now 2. That's just to tell you that when you add the power together, it must give you 3. When you add this one and this one together, it must give you 3. When you add this one and this one together, it must give you 3. When you add this together, it must give you 3. When you add this one together, it must give you 3. It's not a magic. It's just a procedure that you need to follow. Now, moving forward, we have s raised to power 3. Anything raised to power 0 is equal to 1. 1 over x raised to power 0 will give you 1. So 1 multiplied by s raised to power 3 will give you s raised to power 3 plus, this one as well. We have s raised to power 2. This one will give you s raised to power 2 times 1 over x, okay, plus s, this one is s, times what? Times 1 over s raised to power 2. Because 1 squared will give you 1. Plus, anything raised to power 0 will give you 1. S raised to power 0 is 1. And this one will give you what? 1 over s raised to power 3. Because 1 raised to power 3 will give you 1. Okay? Now, s can cancel this one. S can go to A. So we are going to be adding s over this to raised to power 3 to be equal to s raised to power 3 plus this one will give you 3s, and this one will give us what? 3 over x plus 1 over s raised to power 3. Now, this one is having power of 3, this one also is having power of 3. You can bring them together and have some things there. S plus 1 over s raised to power 3 equal to s raised to power 3 plus 1 over s raised to power 3. And this one, 3 is common here. I can factorize 3. If I factorize 3 here, I'm going to have 3s plus 1 over s. Okay? Now, if you look at it very well, this thing is similar to this, because we have been given this thing in the question that s plus 1 over s is equal to 3. This one is similar to this one. And we have to find this. If you look at it very well, this is what we have to find, and this is it. So you can just make it the subject of formula. You can just bring this one out. You can bring this one to the left hand side and bring the other to the right hand side. Let's do that. We have s raised to power 3 plus 1 over s raised to power 3 to be equal to this s plus 1 over s. That's if we collect the like terms. Bring this one to the side. Minus 3s plus 1 over s. Now recall, but s plus 1 over x is equal to 3. But s plus 1 over s is equal to 3. So we are going to be putting this inside this. Therefore, our s squared plus 1 over s squared will now be equal to, we have s plus 1 over x to be equal to 3. So we put 3 to represent this one. Minus 3. This one also, we use 3 to represent it. Okay? I think this one we are looking for. Okay, so that's 3. And that will give us 3. This time this is 9, and that will give us minus 6. That will give us minus 6 at the answer. Because the question has to find s raised to power 3 plus 1 over s cubed. And this is s raised to power 3 plus 1 over s cubed. And that is that about that. But I think we should just check again. From here, we have s raised to power 3 plus this one we cancel this one to give us 3s. This one we cancel this one to give you 3 over x plus 1 over 3s. And we bring this thing to the right hand side here. We bring it to the other side. Okay, I think here we have power of 3 in this place. And they have forget it. Okay, let's do that again. From here. Divided by therefore, from here we have s raised to power 3 plus 1 over s raised to power 3 to be equal to, this is now 3, and we have power of 3 on it. So it will be 3 raised to power 3 minus 3. This is what 3 did there. We have 3 raised to power 3, and that's 27. 3 times 3 is 9, 9 times 3 is 27, minus 3 times 3, which is 9. So we subtract this one. Okay, let's firstly remove 7 from 7 to remain 20. Now remove 2 from 20, that's 18. And that's 18. This is the reason why we need to be checking our answer. If you feel that you have finished the work, just cross-check your answer, the procedure, and you know if you get it right or not, you'll be able to see it again. Thank you.